Identify the target reaction and the two given reactions at 1000 Kelvin. The goal is to determine the equilibrium constant, KEQ, and the sign of the standard free energy change, delta G degrees, for the target reaction. 2FeO plus C is an equilibrium with 2Fe plus CO2 quad. We are given two individual reactions at the same temperature. Reaction 1. 2FeO is an equilibrium with 2Fe plus O2 with KEQ1 equals 1 times 10 to the power minus 6. Reaction 2. CO2 is an equilibrium with C plus O2 with KEQ2 equals 1 times 10 to the power minus 32. Determine the mathematical manipulations needed for the equations. To obtain the target reaction by adding the given equations, we must arrange the reactants and products appropriately. Reaction 1 is kept exactly as written, meaning its equilibrium constant remains unchanged. Ka equals KEQ1 equals 1 times 10 to the power minus 6 quad. Reaction 2 must be reversed to place solid carbon, C, on the reactant side and carbon dioxide, CO2, on the product side. When a chemical equation is reversed, its equilibrium constant is inverted. Kb equals 1 over KEQ2 equals 1 over 1 times 10 to the power negative 32 is equal to 1 times 10 to the power 32 quad. Verify the sum of the manipulated equations. Adding reaction 1 and the reversed reaction 2 yields the target equation because the oxygen gas, O2, appears equally on both sides and cancels out completely. 2FeO plus C plus O2 is an equilibrium with 2Fe plus O2 plus CO2 quad. 2FeO plus C is an equilibrium with 2Fe plus CO2 quad. Calculate the overall equilibrium constant, KEQ, when adding chemical equations to find a net reaction. Their individual equilibrium constants are multiplied. KEQ equals Ka times Kb quad. KEQ equals 1 times 10 to the power minus 6 times 1 times 10 to the power 32 equals math 1 times 10 to the power 26 quad. Determine the sign of the standard free energy change, delta G degrees. The thermodynamic relationship between Gibbs free energy and the equilibrium constant is defined by delta G degrees equals RT ln K quad, because the calculated equilibrium constant, KEQ equals 1 times 10 to the power 26, is significantly greater than 1.0. The forward reaction is highly favored at equilibrium. Mathematically, when K greater than 1, ln K is positive, which makes delta G degrees negative. This corresponds directly to option D. The correct answer is option D. Kek is equal to 1 times 10 to the power 26. Delta G standard is negative.